Hey everybody, I wanted to go over question 2 on the exam here. So it says, and so this is kind of a standard equilibrium question, or equilibrium acid-base question. So we have our calculator and we're ready to go. So it says calculate the hydronium ion concentration of a 0.05 molar solution of HOCl. So that's hypochlorous acid. Okay, so let's do that. So the thing to do is to draw a reaction, or to write a reaction. So remember, there's only one acid reaction ever. Okay, it's the acid plus water gives the hydronium ion plus the conjugate base. Okay, so now I'm going to look at this and I'm going to do an ICE chart. ICE. Now, initially, we have 0.050 molar of this thing. Water doesn't matter, and then we don't have any of this or any of this. So now, because this is a reactant, we're subtracting it. This is plus X, this is plus X, so this is 0.05 minus X, this is X, and this is X. Okay, so now from here, we can write the equilibrium expression where you have Ka, which in this case is 3.1 times 10 to the minus 8 equals products, which is X times X all over the reactants, 0.05 minus X. And so now we just solve for X. So in order to solve for X, we go through, let's turn this on. We're going to 3.1 times 10 to the minus 8. Okay, now to do this, we're going to cancel this out because of the 5% rule. So now we have to multiply by 0.05. Okay. And then we take the square root because this equals x squared over 0.05. And so we're going to multiply by this and then take the square root. So we're doing the second square root of that answer. And so we get that x equals 3.94 times 10 to the minus 5 molar. Okay, so that's the concentration of the hydronium ion. Now in this case, we didn't ask for the pH, but you could easily figure that out. Okay, so now part B says do the same thing when you have 0.05 molar HOCl, hypochlorous acid. I was reading this, acid with 0.02 molar sodium hypochlorite. So now the same thing here, we're going to do a reaction. And remember, it's a weak acid. There's only one weak acid reaction. And now for this reaction, we'll make our ICE chart. And so when we make our ICE chart, this is 0.05 ICE. This doesn't matter. This is still 0, but now this is 0.02, right? So this is 0.05, that's this guy, and this is 0.02, so that's this. Okay, so now we're going to go minus X. Remember, the reactants are used up. And this is plus X, so that gives us 0.05 minus X and 0.02 plus X. So now we can go back to what we know how to do. We're going to do Ka, which equals 3.1 times 10 to the minus 8 equals products X times 0.02 plus X, right, the products, divided by the reactants, 0.05 minus X. Okay, so now using the 5% rule, we're going to get rid of this x and this x. Okay, so now this can be simplified as x times 0.02 over 0.05. And so now we solve for x. So now we just do a little bit of cross multiplying. So 3.1 times 10 to the minus 8 times 0.05 divided by 0.02. And so we get that we get that x equals 7.75 times 10 to the 8th, 10 to the negative 8th molar. So, and again, that gives us our hydronium ion concentration. The problem did not ask for anything other than the concentration of the hydronium ion. It didn't ask for pH or POH or anything crazy. So that's our answer, and it's pretty cool. Have a great day.